Thank you everyone. To navigate Asia supply chain with DIGITIMES and with confidence. And many of my friends here, you may know me something about before, but some of them, you may not be familiar with me. So let me introduce myself, introduce DIGITIMES a little bit, then I will introduce you my observation about whole Asia. I went back to Taiwan in 1985. That year was a taking off year of Taiwan high-tech industry. Not because I went back, because Microsoft launched Windows, because Taiwan started to produce IBM compatible PCs. Then we have scale. Then the semiconductor industry, we started from 1970s. We have a space, room for development. So we expand our industry, especially in 1990s, very successfully. It also because of the American buyers, like Compaq, HP, Dell. They purchase a lot from Taiwan. Then today, you may find out more than 80% of the notebook PCs produced by Taiwanese makers. Most of the servers, even most of the iPhones, they're still produced by Taiwanese makers. Then we have very successful industry. Maybe you didn't know, until end of last year, we have 949 listed electronic companies. Even we only count those companies together, their revenue as big as $953 billion, which means every listed company, they have $1 billion, about $1 billion revenue yearly. This is a big deal. We purchase a lot of different component devices from the industry. Only mass producers, companies like Foxconn, like Wistron, Compal, Quanta. Only top 6, their revenue last year was $400 billion, which means they have to purchase at least $300 billion value of components from outside. So that's a big deal. We are the most important portion of the supply chain. And personally, I'm lucky because before I went back to Taiwan, I studied in Korea. So I speak Korean well, better than my English. Sorry about that. So I always talk to my friends. I speak 4 languages, but unfortunately, English is the worst. So I try with my best to let you understand what I'm talking about. And the year when I went back, government recruited 20 young men to formulate a strategy for the country. I'm one of them. Actually, I'm the youngest one. And I was assigned to Hsinchu Science Park to formulate a strategy for Science Park. Then I'm the one of the writer of the first version of Taiwan's computer industry development plan. There's a think tank called MIC. And later I became the boss, big boss of the MIC in 1990s. And I always say I'm lucky because when I was a big boss of MIC, we don't have internet, we don't have mobile phone. So all of the industry leaders, if they have any questions, they call me directly. There's a reason why I can start up DIGITIMES 1998 successfully and very smoothly. So DIGITIMES co-invested by 40 industry leaders, includes Morris Chang, TSMC founder, includes the Acer, MediaTek groups, their founder, their chairman. So we co-invested, but we have a rule. All of the industry people, our shareholders, cannot hands-on. So I'm in charge. I'm the founder and the chairman, president of the company. And recently, we also acquired a new enterprise, a new company called IC Radio. Do you know that? Which is a radio station located in Hsinchu Science Park. So we have the same protocol to talk to the industry people. So it's our background. So DIGITIMES publish 90 to 100 articles, news every day. We also publish 300 reports yearly. But after year 2018, we found our American subscribers increased dramatically. And actually, 2 days ago, we hit a record height. More subscribers, more readers, they want to know what happened in Asia. Or even last month, we have two gentlemen, one from Infineon and Bosch from Germany. They say we want the most reliable and updated information about the whole Asia. So it's lucky for me. As I say, I'm the founder of the company. People say I'm the best Korean expert in Taiwan because I speak Korean well. And also I travel to China, more than 100 major cities all over the country. So that's my background and the experience before. So I try to let you know key issues behind IC supply chain. So people talking about AI, talking about quantum technology, but also think about US-China trade war, emerging markets. Now India is more important than before. And only 3 months ago, I was invited by Indian government to participate as a keynote speaker for Asian Economic Dialogue. I show off my face on the same stage with the founder of Infosys, the biggest BPO company in India, Murthy. Actually, you know that. Murthy is father-in-law of British Prime Minister. So he's a hero of India. And we discussed many things about the AI, about the metaverse. And I believe India will become a key player in the future, especially IC design and new opportunities from metaverse related. And diversified manufacturing, not only, actually, I just talked to our friend from MediaTek. I say, if you know, Foxconn has a factory in Zhengzhou. They produce iPhone 4. And the most of the time, they have the employees more than 300,000. But chairman of Foxconn, he also asked me, if they go to India, how can run the business like Chinese way? I say, don't run the same way. It's impossible. I talked to Finbar. I say, do you know what is the national name of India? People say, must be India. I say, yes, must be India, but their real name is United States of India, because the country has 29 different states. They may different from China. So different languages, different religions, something like that. So we need to understand which is a diversified manufacturing, but in the year 2030, India total GDP will be bigger than Japan, become the number 3 in the world. Today, India is number 3 automobile market in the world, number 2 mobile phone in the world, number 1 two-wheels bike in the world. If they become electric vehicles, they will become the biggest market in the world. So which is the massive market, not only India, but also Asian countries. 2 days ago, I also got an invitation from Singapore for their annual day, Semiconductor Association. I'm going to become a keynote speaker in September to Singapore. They also like to know. I say Singapore took a very different approach compared to Taiwan. Taiwan has our native industry. So we say our industry style is inside out. When Singapore is outside in, there is a totally different approach. We need to think about what's different between us. So I try to give you some idea about that. And during Cold War, we say Japan, Korea, Taiwan are in the front line, which is silicon shield. And today, looks like same, because semiconductor. Most of the memory ICs produced by Korean makers. And 2 weeks ago, I was in Seoul. and I met many industry people, and I also met Samsung friends, and they want to know, because the industry structure is changed. So, and Taiwan produce most of the advanced chips now. And I believe within 7 to 10 years, Taiwan will still keep the leading position. And why of that, I will answer you later. And I believe the new battlegrounds will be in Vietnam, will be in India, and Thailand. Thailand is because of the automobile industry, and Vietnam is most easier and convenient when we migrate from China to other countries for mass production. And mostly they go northern part of Vietnam. But 2 months ago, I went, thank you. 2 months ago, I went Ho Chi Minh City for invitation. I try to look around to understand, I give them some advice. Don't try the same thing with the northern part of Vietnam. Northern part of Vietnam, they focus on notebook PC and mobile phone manufacturing. If they go to Ho Chi Minh City, industrial PC and semiconductor will be more important, or IC design, they would take different approach compared to other countries. And if you go to India, don't forget the India opportunities and the window to Africa. You know, in Africa today, they have 1.4 billion population as well, and higher than 90% of their mobile phone penetration rate. And can I ask you a question? Which country is the biggest country population in Africa? Do you know that? Yes, Nigeria. About 200 million people live there. Their mobile phone penetration rate now is higher than 90%. They use mobile banking. So there's a mega trend, and in the future, mobile phone not only, but also in the future, maybe metaverse, young youth generation, something like that. But PC mobile phone production site shipped to other countries. And we have, as I know, at least one quarter of the mobile phone now, iPhone now produced in India. Rely on 3 major companies, Foxconn, Pegatron, and Wistron. And I believe they will localize and co-work with local companies. So I talked to my correspondent in India. I said, you need to deal with the local telco companies. You need to deal with the top 5 automobile makers. But don't forget, India has 80 unicorns. You need to deal with them. Not only for mobile phone, TV set manufacturing, but also for servers, data center in the future. So that is my suggestion to you. So Taiwan, we have a very successful story. You know, as I say, we start from scratch. No any other country in the world like Taiwan run the business so successfully. I'm not saying Korea is not good. Korea is very good. Only Taiwan and Korea success in semiconductor history. But we took different approach. In case of the IC design, Taiwan contributed about 18% of the worldwide IC design industry, when Korea only less than 2%. Not with Taiwanese smarter than Korean. It's about downstream industry, because mass producers. So it's easier for Taiwan to contact to Taiwan to their partners. So you may didn't know. DIGITIMES is a daily newspaper with hard copy paper, with hard copy. Because Taiwan is smaller, then we got the opportunity. And until today, 88% of DIGITIMES hard copy subscribers live in Hsinchu and Taipei area. It's 1 hour distance. So we are the most successful to run hard copy media in Taiwan. But looks like we are media, but I just show off that you know we really publish 100 articles every day. So it's not our business. It's just a face of DIGITIMES. But Taiwan so special. Then we have the scale like this way, as I mentioned, 949 listed companies, many producers over there, and that's why we have a very successful semiconductor industry. With the semiconductor industry, we have $175 billion. Distribution means two things. One is component distribution. Another one is 3C distribution, wholesale. The biggest wholesale distributor, which is Hynix. Hynix also has a big operation in America. Hynix chairman is one of our major shareholder. And another component distributor called WPG. And WPG is the biggest one, as I know. They have $28 billion revenue last year, and a very successful one. And before I went to India, I asked my assistant to collect data from major 5 countries that export semiconductor to India. My assistant told me the 5 major countries export about $11.4 billion semiconductor to India, but more than 70% from China and Hong Kong. Can you believe that? Absolutely not. China and Hong Kong not enough strong competitive semiconductor to sell components to India. So Taiwanese company operate Hong Kong as a warehouse to distribute all of the components, or Foxconn, Wistron, Pegatron become a reflection to Indian market. So that is the truth today. So once I discuss my good friends who in charge global marketing, and I ask him a question. You always say Taiwan, China, and Korea contribute about 20 to 20% for equipment supplier like applied material ASML, but actually China is not 22%. If you count the contribution from multinational companies, China will be less than 10. So that is the truth, but people cannot just get data, numbers from outside and cannot judge that. So there is a challenge for us to understand that kind of things. And the optical electronics, we can divide it into LED and LCD. So it's not difficult for you to understand Taiwan, because Taiwan government acts, every company need to deliver financial update monthly basis. So it's not difficult for you to understand and trace back. So it's not difficult at all. And my vice president Eric Huang, he take care in charge of our research job for many years, and he conducted a survey about top 30 electronic manufacturing services. And for Asia supply chain includes industry from automobile, tech products, and semiconductor as well. So he say includes automobile. I emphasize again, and he say among the top 100, Japan contribute Japan has 34 companies from Japan and 37 from China, 11 from South Korea, and 14 from Taiwan. They are the key players and the powerhouses in this kind of field. And we can trace more detailed data. Actually, I just talked to my friends recently. I say we're trying to build a situation room for you to update information by AI. That is possible for us. Most of the up-to-date and reliable information from Asia supply chain, Taiwan is a key player. And if we have the partner from Korea, then we can do things better. There is a reason why I went to Korea 2 weeks ago. We deal with 3 companies, try to gather all of the information together to try to serve you. So global semiconductor industry, mostly people, especially Western-based research company, they will focus on this kind of map. Market-wise, we have $575 billion, and maybe a quarter of them, they are memory IC, and non-memory IC will be about 77%. But once you go to the end market, computing devices will be 33%, and the communications 35%, consumer electronics, automobile, and the industrial PC will be 10% respectively. But if it goes to computing devices, we need to identify 2 different categories. One is personal computer, another one is server. So just when Jensen Huang visited Taiwan TV station say NVIDIA has 20% their revenue derived from China. I say, okay, let's think about that. If there's GPU sell to servers market, we have to identify 2 different approaches. One is manufacturers. Maybe you didn't know, 93% of the servers produced by Taiwanese makers. So if makers decide which components they choose for, then Taiwanese will be the decision maker. And if you say China, China among the top 10, they have 3 companies like Spur, like Lenovo, like Ali. They contribute about 12%. There is a precise number for you to understand who contributed more and who are the key players in the field. In case of the communications, Yes, mobile phone is most important, then networking products, routers and others. So, but I will strongly recommend you to understand industrial PC in the future. And in Taiwan, the top 6 mass producers like Foxconn, Quanta, Wishon, they are big, but their profit is not good as you maybe only 5 to 7% only, but the net profit will be 10%. But their strength is turnover. So their turnover is very fast and efficient, no room for error. There is a strength and experience accumulated before by Taiwanese makers. But take different way to think about specific for AI, AIoT market. Industrial PC company will play a very important role. So you need to contact those companies, like Advantech, like many companies. We have about 20 to 25 industrial PC companies are listed company. Normally, their gross margin range between 35 to 40%. So it's not difficult for you to understand that. And people only know TI, Intel sell their components or MediaTek sell their components to the market. That is true. But 1/3 of them, they're sold by component distributors. Companies like WPG, RT, and Evernet, Arrow in Asia, they run very successful too. And I believe 35% they go through this channel. But when we back to industrial perspective, there is a totally different. You know, maybe market-wise, we need support from fabless companies like MediaTek and the TI, Intel, like IDM companies. They combined together, which was $575 billion, but we have $139 billion from Foundry, and the $42 billion from OST, and the $22 billion from companies like Cadence and Synopsys. And also we need to pay attention on equipment, materials. Several years ago, I was invited by our government to go to Chicago. We set an appointment with a company called Cabot. I'm not sure, do you know this company? C-A-B-O-T, Cabot. I paid visit to them. I didn't know them, speak frankly. But they have 5 vice presidents, senior vice presidents to see me. I asked them, Taiwan so important for you? They say, yes. I say, which company is the biggest company of your customer list? He said, TSMC. TSMC contribute about 25% of their total revenue. I said, now I believe at least 1/3 your revenue from Taiwan. They say yes, several years ago. Because UMC, because Mechanics, like Winbang, they also contribute a lot for the international society. So I just disagree. Your ex-president say, Mr. Trump say, because Taiwan took your jobs. No. We play a critical role to enhance your value chain, and we can work together better. Otherwise, if all of the Americans to go Asia, you cannot run the business. No, because which is the Asian way. We need to know, we need to work together and enhance, improve all of the process. And I try to give you a perspective from industrial value. So in case of the local industry, Taiwan, we have $175 billion. As I mentioned, whole industry, maybe we only have 47 IC designer in Taiwan. But as I say, we contribute 18% of the worldwide. And I believe Taiwan will co-work with India in the future, especially in IC design job. According to the data, actually, thanks for MediaTek, you subcontract a project for which is IC Design Yearbook of Taiwan year 2023. We organized the report, composed that reports for the industry. And Eric Huang, he is the project leader. He told me in India has 57,000 IC designers, but they don't have IC design industry now because they work for multinational companies. But it's about industry portfolio and the stage, different stage. Based on PC and the mobile phone stage, India didn't have brand names. That's why they don't have the influence in the end market. But in case of the future, I mean automobile and the metaverse market opportunity in the future or edge computing, you can believe India will create more opportunities locally. That is the new mega trend. So I believe we will work with them more closely. Then, as I say, our IC industry design is quite important. They contribute 23% of the Taiwan total revenue, and the foundry now is the most important industry. Then OST, and we have about 55% packaging and testing industry worldwide share in Taiwan. So most of the manufacturers, they need to co-work with Taiwanese makers for end products, for final assembly. People ask me, if China and Taiwan will fight in recently, I say no, it's difficult. It's my personal opinion. It's about advanced technology, advanced chips, as you know. I don't want to emphasize again. But you may didn't know. The top 30, only for electronic manufacturing, top 30 companies last year, total revenue bigger than $500 billion, but 72% are Taiwanese contribute revenue. That's one thing. Secondly, for Korean companies like Samsung and SK Hynix, you may didn't know, last year, Korea trading deficit as high as $47 billion. But you didn't know, Korean semiconductor industry contribute 57 billion surplus from semiconductor, which means if Korea cannot make profit from semiconductor, their deficit higher than $100 billion. Especially for Korea is a country, external debt higher than $660 billion. There is a challenge for Korea. So if they lost the partner of Taiwan, they are going to lose and even face the bigger challenge than Taiwan. So I just believe people need to keep the ICT supply chain secure, safety, then we can do things better. And I have another idea, maybe you didn't know. I'm the board member of China Airlines. And the chairman, president of China Airlines told me that among the top 10 air cargo airports in the world, 5 of them are in the Eastern China Sea. Biggest one is Hong Kong. Second one is Incheon. Third one is Shanghai. Fourth one is Taoyuan. Fifth one is Narita, Japan. So we all in Eastern China Sea. If war happens, and there's not things, not only for Taiwan, but also for Japan, Korea, for every country, and even China. And that's why I say, or I want to add one thing. Do you know which one is number 6? Anchorage, Alaska. And Singapore is number 10. So we all in Eastern Asia. So there is a challenge for everyone. So I just try to let you know changes in semiconductor market share. In case of the market, we have the value from IC design house and IDM companies. In Taiwan, we have many IC design houses, that is true, but we also have 3 IDM companies, Winbond, Mechatronics, and Nanya. They also contribute $8 billion. So totally, we have 8% of the worldwide market. But in case of the industry perspective, we have 18%. That is bigger than you imagine. So especially for advanced technology manufacturing, Taiwan is more important than you know. So there's maybe secrets, but I know after year 2009, TSMC became the real industry leader in the world standard. After year 2009, they invest at least 1/3 of their total revenue into CapEx, especially after year 2019. When they invest 7nm process technology, they're even higher than 40% into CapEx. And into CapEx, now is about 45 to 50%. No any country is like that way. So I always say TSMC has 3 pillars for the success. One is technology leading. Second one is ecosystem. Third one is about client structure. As I know, maybe TSMC has 500 key clients, and Samsung maybe only have 120. And recently, I have heard from C.C. Wei, CEO of TSMC. He say, if you want to co-work with core clients, key clients, at least you need 2 years to deal with them. Leading times is longer, and that is difficult for them. And we just published new articles and reports about GAA 3 nanometers, which is the hottest news yesterday of DIGITIMES English version. You can try to get that. And we co-work with Tech Insight for introducing the most technology was different from TSMC and Samsung. So there's status, but time is limited. I cannot spend too much time, but I just try to let you know, maybe our technology is not a lead. I mean, TSMC maybe not a real leader, but our reliability is the best. So looks like spec highlights Intel for the high standard, high quality, but it depends, customer needs. And can you fit with a higher yield rate? That is the key in the business. So it looks like they have different roadmap, but TSMC obviously they have a better result. So in the first quarter this year, they have 60% worldwide share already. So there is a big challenge and not very difficult to catch up, because my secretary told me TSMC has a very special strategy. I said, what? My secretary can tell me that. He said, shake hand. They squeeze all of the Taiwan resources into one company. Now they squeeze all of the information into one company from global basis, not only Taiwan. They take loan, they take a subsidy from maybe Japan, Germany. Everyone welcome them. So they want the manufacturing from their national security issue. So the world is changed. We need to understand decentralized manufacturing, but core technology maybe rely on specific companies. That is different from before. So I say process technology, client structure, ecosystem, but if you want to try three together, you may stuck in the middle. That is a challenge for everyone. So now many countries invite us to go to share with them. Several months ago, I came here to Stanford University to meet some people to discuss about the status of our environment. Do you know who sits in the middle? Jim Ellis. Do you know him? He's a 4-star general. And he told me 28 years ago, 1996, sorry. He went Taiwan Strait. He led a fleet. He was 4-star general. He asked me, are you pilot? Because I wear pilot jacket. And I say, I'm not. He said, I am pilot. Because he's, as I say, Navy pilot before. But I appreciate that. I asked him, how old are you when you lead the team to, you are the commander to Taiwan Strait? He said, 48 years old. So I talked to my young man. We need to learn. You have the ambitions, you have the viewpoint and ambitions to think about the future of for yourself. So new battleground, as I mentioned, but you need to know who are the real players in the field. As I know, companies like Avnet, Arrow, or WPG, they identify their customer into three different kinds of customer. One is CBM, two is TBM, then NBM. CBM means Chinese-based manufacturer. TBM is Taiwanese-based manufacturer. NBM means multinational. And we need to enhance or enlarge multinational companies to get more opportunities. But multinational company not means for IDM, not means for TI, Intel, or Samsung. They means for local big giants. So every country they have one local king. In Vietnam, maybe we know the company called Vinfast or Vingroup. In India, we have TVS. We have some companies. And in Thailand, we have a company called Hana. They're all local mass producers. Then we need to work with them to help them to build their local facility to help people localization. There is data I mentioned to you before, more than 70% from other countries. So the best magazine of Taiwan, Commonwealth, they invited me to write my next book I choose the subject to become my next book name, World Semiconductor Classic Quarterfinals, because only 8 countries will be the key player. I believe absolutely America will be the first, and then Taiwan, Korea, Japan, Germany, and I believe China will be the number 6. And who's number 7? I believe India. I beat India. And who is last one? I'm not sure. I should choose a name like White Card, because ESG, because Canada, Australia, Singapore all have the opportunity to become a key player in the field. So we try to organize this book, compose this book. If anyone want to publish my English version, please let me know. So we try to do something like that, give you a clear picture about that. There is a data from WPG, Smart Logistics. And once I sit next to WPG country manager, China, and he asked me, do you know how many white box assemblers in China? About 10 years ago. I said, I don't have any idea. He said, 350. I said, how you know that? Because, he said, because we help them to give them field assistant engineering support and warehousing finance support as well. And they identify who are the key players, who are the key customers in this kind of field. And today they try to do vertical market and customization solutions with big data and AI. So they have a very big warehouse and backup solutions for that kind of logistics. That is one of the Taiwan strengths. So as I mentioned, company like MediaTek, if you design a components, you need to sell to WPG, then sell to HP, then sell to Quanta, sell to Wistron, and then sell to HP Dell, which is the linear supply chain. It's very clear cut. But today you try to sell more components to industrial PCs, which is a matrix network, different from before, and then you need to localize, which we need, smart logistics and smart manufacturing. So this is what I try to let you know. We need to integrate intelligence and marketing together. So a lot of obstacles will be happen in the future, and we need to solve that kind of problems together. And which is I suggest to South Asian countries to try to take this way. Work with Taiwan to build smart city and to build Hsinchu Science Park in your country, and together. Then we can get a better infrastructure and the platform to work together. Something like data center and hardware, software. Time is limited. I cannot spend too much time, but I try to convince you. A lot of things we can work together. And DIGITIMES is a company. Looks like a media, but actually we have 10% of the revenue from consultancy. We get the project, research project, work with famous company, forecast company together, and we have 45% about our revenue from paid members. There is a very secure and a very stable business model, and also we have about half of our revenue from marketing events. So, yes, Samsung treat me very good. They invite me as a torch relay player 5 years ago to Korea for Olympic game. So thank you for your attention. I hope you can understand more about DIGITIMES, and if you have any questions, please let us know. Thank you. Thank you.
Good afternoon, everybody. So first of all, I'd like to just thank Collie and Eric and the guys from DIGITIMES for the opportunity to speak to you today. I'm Finbar. It's a complicated Irish name. I'll tell you about it afterwards if you're interested. But I've been at MediaTek for about 15 years, a survivor, as I like to say. So I'm going to try to give you a little bit of perspective today from MediaTek as basically a supplier of SoC and connectivity solutions, and how we see the trend of AI adoption in our industry, and how it's perhaps impacting the semiconductor industry overall. So the way I was going to structure the talk today was I'll introduce a little bit. I am by no means an expert in AI, so please take this with a grain of salt, but at least some sort of thoughts on AI technology and how we see it developing, and maybe some comments in general about how we see the impact on the semiconductor industry. I'll very quickly, and I mean very quickly, introduce where MediaTek plays in the industry as a sort of a provider of smart edge solutions. I'll then talk a little bit about our architecture for how we implement AI in our SoCs at the edge, so across a host of different applications, both on the hardware and on the software side. And then I'm going to go into, at the end, just a few examples from mobile, our smart TV business, and our new automotive business, and show you sort of examples of where AI is already being deployed and will continue to be deployed in the future. And then hopefully I'll wrap up with a few comments, conclusions, and insights that'll maybe bring some insight. I wanted to start with this quote from Bill Gates because he published it recently, I think in March, and I thought it was quite insightful, where Bill Gates basically put AI technology at the same level as the creation of the microprocessor, the personal computer, the internet, and the mobile phone for the technology industry. And I think, you know, all of us in the industry, I think, have enough experience to know how much these trends shaped the semiconductor industry over the last decades. And so I think, you know, given this level of profound sort of awareness of AI technology, we can expect that it's going to have a significant impact on all of our businesses as we go forward. And in fact, we're seeing it already. As a way of sort of grounding the talk, I thought it would be useful just to reflect very, very quickly on some of the history of, you know, AI technology in general. And I thought this paper, the references at the bottom from Jaime Sevilla and his team of co-authors from the University of Aberdeen and other institutions, I thought just crystallized some of the history very, very concisely. So I thought I would just share this one with you. The first phase, the first era, the kind of yellow part of the graph, is what they call the pre-deep learning era. And it was essentially an era that was driven by the very well-known Moore's law, where, you know, computing was generated or was accelerated by the adoption of Moore's law. And we saw the performance double roughly every 20 months, something like that. The second era, which they call the deep learning era, they pinned starting around 2012 with the launch of AlexNet, right? So the visual recognition neural network designed by Alex Krivetsky and some of his colleagues. But basically a convolutional neural network that was trained on a GPU that outperformed more traditional methods of image classification. And you can see that with the blue area, the curve changed, and performance after that started doubled about every 5 or 6 months. And the current era, which they call the large scale era, they put the start of that with the launch of the AlphaGo model from DeepMind in about 2015. And again, you can see the red curve where performance has been sort of accelerating at the rate of about doubling about every 10 months. So I thought it was just useful to kind of think about these as sort of 3 different eras of machine learning and AI over the last decades. Looking a little bit more recently at the deep learning era and the large scale era, you know, if we look at something like AlexNet that I mentioned in 2012, and we look at the more recent, you know, generative AI models like GPT-3, you can see, first of all, with the number of parameters in the models or in the network, AlexNet about 60 million, GPT-3 and about 175 billion. It's about a 3,000x scaling in the number of parameters. On the other hand, if you look at the training requirements on the vertical axis, they've gone up about 300,000 times at the same level. So again, the computing demands for the training of these networks is accelerating much, much faster. Of course, that is simultaneously enabled by the capabilities of the semiconductor industry and, of course, in the cloud, and also driving new demands for more innovative solutions for those cloud-based solutions. Looking at it from MediaTek's perspective, which I think we're best known as a supplier of solutions for edge devices, we've actually seen the adoption of AI for probably about a decade already. Now, the early models were basically based on voice assistants. I'm not going to name them because that'll set off everyone's phone in the room with requests for data, but you know what I'm talking about. But we saw a lot of that in a whole bunch of different applications, not just mobile, but also in smart speakers and smart displays. And most of those were simply run on the traditional CPU, GPU architectures that were in the SoCs. But in 2020, we worked with Amazon to launch an optimized SoC for smart speakers that integrated Amazon's own IP, their neural edge engine, which began to do more efficient, more localized processing of those speech and voice commands at the edge. I think the next major phase was really around photography and images, and I'll talk more about that later, but AI has added a huge amount of capability to object detection, noise reduction, image quality enhancement. More recently, we've seen a lot of these being applied to video and gaming applications, which I think at the top level, you can think of as sort of similar requirements to image. They just need to run for a lot longer with motion. So the power consumption requirements, particularly for mobile and portable devices, becomes much, much more significant. But I'll again show some examples later where we apply this for things like super resolution and other capabilities. I think going forward, we're going to see AI play a huge role in the whole virtual reality, augmented reality as well, where AI technology is going to be able to enhance the face tracking, the eye tracking, the image processing, the creation of some of the content much, much more effectively than traditional approaches. And of course, you can't have a talk about AI without mentioning generative AI at the moment, but I think it's the hot topic right now. I'll have some comments later. It's clearly the next big thing that's coming, both in terms of chat or image video generation, things like stable diffusion, and of course large language models like ChatGPT that are extremely popular. I thought it would be interesting quickly to sort of summarize and maybe just draw some quite simple distinctions between the more traditional analytical AI models and the newer, kind of high profile generative AI models that are popular at the moment. I think at the simplest level, I think of the analytical AI models as trying to enhance the quality of something that already exists. So taking a voice or an image or video input and using AI methods to improve the quality or the accuracy of those. Generative AI is about generating completely new content, so they're very, very different. At the top level, we talked a little bit about it, the number of parameters from tens of millions, typically in the analytical AI models, to 1 billion and many, many more in the generative AI case. Of course, with that complexity comes the computational load for inference or for the actual execution. So computation per inference in analytical AI is a few tops. It's thousands of times that in the generative AI case. Convolutional neural network models are much simpler, more predictive structures in the analytical AI case. And usually what happens with the design, and I'll go into this in the architecture in a moment, these are usually not so memory intensive. They're usually more computational bound, so the performance we can get at the silicon is more related to how much acceleration we have for running the neural networks. On the other hand, the transformer models that are needed in generative AI use cases are more complicated. They tend to require a lot more data. They tend to require a lot more memory access. And from the edge perspective, are usually more bound by the memory bandwidth, the memory capacity, and the memory size. I'm not going to stand here and pretend I can predict the future on where AI is going to take the semiconductor industry. I think we've got experts in the field who are probably much more capable of doing that. But I think there's a lot of predictions. They all share one thing in common. They all are extremely rosy and extremely bullish in terms of what this is going to mean. I wanted to just grab this one. It's from Allied Market Research that you can see here. But their view is, of course, that there's going to be massive growth. They're talking about a CAGR of over 35% per year, a CAGR of over 35% over the next decade or so, which those of us that are in the industry know is well beyond what we can all dream of for the overall semiconductor industry, which is, if we're lucky, a few percent a year. But I thought what was interesting in their data was They also kind of break it out between the cloud and the edge. And I think, a lot of people today are focused on the opportunity for this generative AI in the cloud, and there's definitely an opportunity there. But they have the view, and I think we share the view, that it's going to generate even more opportunity for client devices and edge devices as we go forward. Of course, we all saw the phenomenon recently where NVIDIA crossed the magic $1 trillion, and we know what drove that. To that point, I think we, MediaTek, share the view with a lot of other people in the industry, so it's not, I think, a unique view, that mass adoption of AI will necessitate edge or client-based implementation. I think it's fairly well publicized that the cost of generative AI search is like orders or 10 times or more expensive than traditional search. So just from a pure cost perspective, it's never going to scale implementing these solutions only in the cloud. Of course, there will be cloud implementations for certain functions. Of course, as well, we also expect, we're at the very early stage of generative AI, and we also expect a lot more optimizations to happen in the coming years, from more general to more specific function models. But I don't think the gap is going to close. So we have to look at how we implement some of these solutions on the edge. But beyond just the cost factor, I think there are other factors at play here, right? So for one, there's data transmission between the device and the cloud, which is always a concern, particularly if you're paying for that data transmission. So the more you can keep the data on the device, the less you have to communicate with the cloud, the better. That can also, of course, lead to lower power consumption. But beyond that, it can also lead to reduced latencies. So that can give, again, if we're thinking about applications like augmented reality, virtual reality, latency is critical. You can get a better overall user experience if you can keep more of the processing on the device. There are security concerns, data privacy concerns that are also different from one jurisdiction to another jurisdiction. So again, the ability to keep more of that user information on device can also address some of those concerns. And I think we also believe that with more of the activity happening locally on the device, it can learn over time, it can become more customized to the user, and again, deliver a better overall user experience. So why MediaTek? And I promise I'll be very quick. For one simple reason, we power about 2 billion consumer electronics products every year. If you look into that a little bit more detail, that's in like SoCs or connectivity, or in many cases, both. About over half our business is in mobile phones, smartphones. Since 2020, MediaTek has been the largest supplier of AP SoCs for the smartphone industry by volume. So we supply more apps processors into smartphones than any other company. But beyond that, if you look at the yellow part, you look at smart TVs, you look at multimedia SoCs for smart speakers, smart displays, OTT and streaming media devices, ARM-based Chromebooks, Android tablets, we have a #1 market share. But beyond that, we also have a growing business in automotive, industrial, and IoT. We also have an ASIC business serving some of the needs of the cloud and data center that can also impact this. And basically, if not already, most, if not all of these businesses are already or will be affected by this AI trend that we're talking about today. And that was it on MediaTek. That was the marketing pitch. What I wanted to do next was to sort of delve into how we do this. And I wanted to talk a little bit and give you a little bit of insight into our edge AI architecture. So basically, we have a block which we call the APU, an AI processing unit. At the simplest level, there are kind of two different computational blocks. One block, which we call the MDLA, not very innovative, MediaTek Deep Learning Accelerator, is essentially a computing block that's designed to run traditional neural network processing, very repetitive kind of processing for convolutional neural networks, recurrent neural networks, or even for some of the processing that you need for some of the new transformer models like BERT, for example. The second block is what we call MVPU, again, not very innovative, MediaTek Vision Processing Unit. These were thought of by the engineers, not by the marketing department. But again, the MVPU is more like a traditional DSP type structure. So it's a little bit more programmable. It is more optimized for, I would say, handling vision-based data. It can, of course, run neural networks and some of those kind of applications as well, but not as efficiently as the MDLA. So more flexibility, less performance. The overall block, both of these blocks, by the way, I should say, are scalable. So we can just plop down more and more of these if we want more and more performance on any particular platform. Of course, at the expense of more silicon area, more cost. Inside the architecture, we also have a tightly coupled memory for just memory management, and a small microprocessor just to handle the control and other type of functions. Without going into too much detail here, it's just a little bit closer look at the MDLA architecture. I just wanted to point out 2 or 3 factors that we focus on. You'll see later as well, a lot of our APU architectures are primarily driven today by our high-end and our mobile platforms. So power consumption is always an important factor. So it contains, first of all, a optimized convolutional engine to run the processing that's very tightly coupled with the internal memory. If you remember, I said the traditional analytical AI tends to be more computational bound and less memory bound. So we obviously want to try to minimize the amount of on and off chip memory accesses for power consumption. The second thing is we do a lot of memory optimizations for that exact purpose to try to minimize the memory bandwidth. And then the third thing we do is in these mobile platforms, and this is probably scalable to other platforms as well, like TV, we tightly couple those to the other blocks like the camera image signal processing or the display picture quality management function where the AI functions are actually used. And then beyond that, on the hardware, we support versatile data types from like integer 4 all the way up to floating point, again for efficiency and flexibility and power consumption reasons. So how does this work? So this is just some benchmark data from within our own R&D teams. But we've taken 5, you can see them in the bottom right corner, common benchmarks from the AI world. And what we're trying to do here is compare power on the vertical axis with a simple metric of performance, just gigamax on the horizontal axis. And so what you see is the gray curve is 4 little ARM CPUs. The black curve is like 1 Ultra Cortex-X ARM CPU plus 3 big cores. The red is a 10-core Mali graphics core. And then the blue curve is our optimized APU for running these benchmark tests. And what it sort of shows is that the dedicated AI processor is about 27 times more power efficient than traditional ARM CPUs, and about 15 times more power efficient than traditional GPUs. In this case, it's an ARM GPU. So that kind of gives you shows you the advantage, but also has the ability to deliver a lot more processing power as well within the power envelope. Beyond the hardware, we also have to provide software. So we call our software SDK or our software framework NeuroPilot. Again, that's not a bad name, so I can get behind that one. But at the simplest level, it's basically a software framework and a software platform SDK that we provide to both customers and developers to allow them to port their AI algorithms or their AI models to our hardware. At the simplest level, like we provide local PC-based and cloud-based versions of this. For the kind of pre-silicon, before we have silicon available, they can use this to develop and simulate and estimate how the models are going to run. Of course, on the hardware, when we have it available, they can then use it to port to the hardware and actually measure and test the performance. At the simplest level, it interfaces to traditional ecosystem standard AI frameworks, TensorFlow, PyTorch, Onyx, etc. at the top. And then, of course, it maps onto the hardware, onto the APU hardware for optimized performance if possible. But if not, it will use CPU, GPU assets for things that might be new or not able to be implemented on the APU. So on our APU roadmap, and again, you can see we've been at this for a while. We're at the 6th generation last year, APU 6. If you know anything about Taiwanese and Chinese culture, we never have a fourth generation. So we have a third generation and a fifth generation. It's the same thing with elevator floors and hotels in some cases. But we've been launching different versions of our APU architecture for the last couple of years. As I said, the current generation is APU 6. That's basically shipping today in our flagship 5G mobile SoC, Dimensity 9200. It gives you about 24 TOPS of performance or 12 TOPS per watt for a constrained power environment. And you'll see new versions coming out this year and next year as we go forward. So we continue to innovate. We continue to deliver more performance. So with that, what I thought I would do is just give you a couple of examples to show you how we are using AI today and maybe give you a glimpse of what this will enable for the future. So in mobile, as I said, mobile and smartphones in particular, for us at least, are probably the main driver of the APU architectures and the AI use cases today, although we certainly see that branching out into a whole bunch of new areas. For sure, and I have some examples, there's a lot of use cases around the camera and video and gaming, right? So enhancing HDR, super resolution, noise reduction, motion estimation, motion compensation, bokeh effects, et cetera, et cetera, et cetera. We also see some use cases as well to enhance the display. A lot of that is about enhancing what the user actually sees, both with depth maps, depth perception, upscaling to HDR content if the display can support it. But even more recently, we're deploying AI technology inside of the modem, our 5G modem, and I'll talk a little bit about that as well. So this is just one example. I know this spot very well. Collie probably knows it as well. It's just below the Science Park and the Royal Hotel in Hsinchu. I think my boss lives in one of those apartments, but don't tell him I said that. But on the left, you can see the image. And again, I don't know if the quality comes across with the projector, but on the left, you can see the image where we've applied the APU and AI techniques to reduce the noise and also enhance the dynamic range of the picture, versus a solution on the right that doesn't have the AI techniques applied. So I think it's pretty clear what the differences are. In fact, in many cases at this stage with mobile devices, we're probably already exceeding the capability of the human eye when we see the actual picture that the device can take and then process with the AI techniques. You know, the quality, the dynamic range, the reflection of the buildings in the water compared to probably the non-AI scene, I think it's pretty obvious. In the recent generation, as I mentioned, the 6th generation, so that's what's currently deployed on our flagship product. One of the big breakthroughs was that we were able to optimize the architecture for power consumption even further. And that allowed us to take a lot of the techniques that we could implement previously for still images and apply them to video. So again, you know, think of it, video is in many ways the same problem as still image, just you got to keep doing it continuously, so the power consumption is much more demanding. Again, very obvious, video shot with low light, night conditions, original content, you can see clearly the noisiness. I think on the right, you can see after we apply AI and the noise reduction, you know, how much more significantly it's improved. And if you know anything about Taiwanese, they always love to use beautiful women for their videos, so apologies. And here we go again. The other area I think that's been very common for a lot of still image photography has been the bokeh effect, right? So that, you know, effect of keeping the focus on the main image and blurring whatever is in the background. I think what we've been able to do in the latest generation, again with enhancing the AI architecture for power consumption, is begin to apply that to video. So when you see here, when the main character is identified and is tracked, you can see that as she moves to the back of the room, the focus will stay on her. Other people in the back of the room will come into focus. People in the front of the room will go out of focus. And then as she moves back again, the focus will shift from the back to the front. So again, this is all possible through AI techniques on the device. Again, applied to video, so the power consumption is very demanding. But I think you can see that it creates a a richer, more meaningful experience for the video at the end of the day, because you're staying focused on what you want to stay focused on. I mentioned as well the modem, and that's kind of a relatively new area, but again, we're applying some of the AI techniques to that area. Essentially, we use the same architecture as I was describing, just scaled down, and a separate block from what the main APU is. So on the main apps processor, there's a dedicated APU block that does all of the application side processing. Within the 5G modem, there's a similar response, which can be used to sort of track and improve the overall user experience. Daily habits, fast recovery, data roaming. I think we've all experienced situations in things like high-speed trains, going in and out of elevators, areas where coverage is patchy. And so what ends up happening is the device and the network are kind of fighting each other as to which cell to connect to, what's the right connection. I think particularly over time, we can build up a profile, understand what the data is, use AI techniques, and use that to drive the settings in the modem to try to give an overall better connectivity experience for the user. This is a relatively new area, but I think one that's going to continue to improve as networks get more complicated and more dense, and then we can optimize for the user experience better. In our smart TV space is another area where AI techniques are being used quite extensively. I would say on the TV space, logically, we're applying these more to the display and to the picture quality enhancement of the technology. First, we call AI super resolution, and I'll show an example of that in a moment. But that's about basically upscaling HD content to 4K or 4K content to display on an 8K screen, but doing it in a way that's got better edge details, smoother reconstruction. We can also use AI for object detection, and again, sometimes these don't show so well on the projector, but essentially what we can do is recognize foreground and background objects, apply different levels or different settings for picture quality enhancements to each of those, and it'll create a better depth perception for when the user is looking at the display. Of course, for TV screens and monitors, we can also use it to do things like, for video conferencing, enhanced backgrounds, those kind of things. So this is just a quick example of the AI super resolution. So you can see the difference before and after. It seems quite dramatic, where the AI techniques allow us to upscale the resolution to show on a higher resolution display, but with much better, edge reconstruction, crispness than maybe more traditional techniques in the past. And I'll also mention that this is something that's also useful for things like streaming services, where if the network bandwidth is reduced, we know that the streaming service providers have to reduce the bandwidth that's delivered. We can use techniques like this to still upscale the quality from the input and take advantage of the capability of the display or the TV. Another area I wanted to touch on quickly, and I won't spend a lot of time on this, is automotive. Recently, MediaTek launched the new brand, Dimensity Auto. I'll just mention two areas, the cockpit and auto drive, which is the two areas where we see AI technology being used quite extensively. A few weeks ago at Computex in Taiwan, we announced a partnership with NVIDIA to focus on solutions for the automotive market. At the highest level, the two companies are putting together the technology roadmap. We feel like the companies' technologies are very complementary to deliver full solutions for the automotive market. But I will point out maybe three examples where we can use AI in the car, maybe with some generative AI techniques, to create much richer, more capable assistance for the car. We'll also use AI for things like interior sensing, who's in the car, and then personalize the experience for those users. And of course, no surprise, visualization, autonomous, and all that roadmap will extensively use AI techniques as well. So what's next? We kind of touched on it already, but clearly generative AI is going to be the next big thing. It's going to, I think, unleash a whole host of new applications: productivity, constant content creation, assistance, code developments, 3D modeling, the list goes on and on. I think it's fair to say, at least our view, is that the current models are not really practical to run on edge devices today. Of course, there are demos and capabilities being demonstrated. But the current models are just too large to run practically, I think, on most devices. But this is changing, and this is changing very, very quickly. Most of the large language models are extremely memory bound today. Image and video applications will benefit from more APU acceleration as we put it on the device. But again, I think models are also going to get optimized from general models to more specific models for specific functions that are going to scale down. We see work from Google, Meta, and others already developing models that are going to fit on mobile devices. And with that, because I'm told my time is up, let me make a couple of last comments just to wrap up. Clearly, we've hopefully shown that AI is going to drive another wave of innovation in semiconductors, both for the cloud, of course, but also, I think, for the edge. We are definitely accelerating AI into more and more devices, not just mobile, TV, auto. It's going into our IoT platforms, solutions for smart cameras. It's going into Chromebook solutions and a whole host of more applications. And clearly, the next wave of innovation will be driven by generative AI. That's going to need more APU acceleration on the devices, but also I think next generation memory interfaces, more memory management, more memory on the device. And with that, thank you very much.
Okay, before I jump into my presentation, Lisa Su today is in Taiwan. And she will spend 5 days in Taiwan. And 2 months ago, Jensen Huang of NVIDIA spent more than 1 week in Taiwan. And the media had rumors that after he visits Taiwan, he will fly to China, but doesn't. He direct fly back from Taiwan to the US. So why these two important CEOs on AI spend more than 1 week in Taiwan? I will explain later. Okay, so here's my presentation outline. First, I would like to do a brief introduction about Asia supply chain. Okay, here you see, I will introduce the evolution of Asia supply chain. So after the World War II, Japanese first took off, and they grabbed the consumer electronics market share, done great production, and designed great product, then become the world consumer electronic brand leader. Then enter the PC era. So Intel and Microsoft defined the PC standard spec. And the Taiwanese companies follow this spec and the standard, done the mass production, and do the low-cost products. So Taiwanese companies took off. And at that time, Japanese company supply the DRAM and grab the #1 market share, NEC. So they dominate the IC industry at that period. Then we get into the internet era. So internet era's leaders are Amazon, Google, and Facebook. At that time, Taiwanese companies moved their factory to China due to customer requirement to do the low-cost production. Then, so Chinese companies began have this kind of know-how to manage the factory. Then they left the Taiwanese company and do their own business. And the Chinese computer supply chain become more and more established. Then going to the smartphone era. Smartphone era, China has this kind of world biggest domain market. So like Oppo, Vivo, Xiaomi, the great market share, and they established the world best, most competitive smartphone supply chain. Then now going to the data economy and the AIoT era. After the trade war, So the factory in China, the foreign company try to move their factory to Southeast Asia and India. That's the current status. And in terms of IC industry, after Japanese company took off, then during the 90s, Korea focused on memory, Taiwanese companies focus on foundry and offset, so they all grow very well. Then Southeast Asia, like Singapore and Malaysia, but they don't have their own brand company, local own company, just foreign company to go to Singapore and Malaysia to set up their operation there. Then going to the AIoT era, now Chinese become the next emerging powerful semiconductor power here. As Cody mentioned, that we conduct Asia supply chain ranking. 3 years ago, previous 2 years we just count 100 companies, but now we count 150 companies because we want to track Asia supply chain more in details. So here's the current status. We check tech supply chain and the automotive supply chain together. As you can see, the table up front is the top 10 companies there. And I would like to explain more about this table. As you can see, for country basis, India and Indonesia and Malaysia and Thailand owning several companies, but no Vietnamese company here. So for Southeast Asia and India, there's no enough large-scale supply chain companies currently, not yet. So the supply chain company most owned by in China, Japan, Taiwan, and South Korea. China has the most influential supply chain companies, over 100, and Japan 74, Taiwan 36, and South Korea 20. And why Taiwan's numbers have more than South Korea? Because South Korea's industry structure is more like a chaebol dominant structure, but the Taiwanese they grow up from scratch. So Taiwan has more diversified industry structure, more customers, so can nurture more companies here. And if we count these companies by different segmentation, so you can see for telecom products and equipment, China, South Korea, and Taiwan have more shares. But Taiwan has the largest revenue. And for consumer electronics, China and Japan dominate these two consumer electronics segment. And for semiconductor, Taiwan and Korea and Japan. For the Chinese company, they are still relatively small. And for the electronic components, you see those four countries has their own electronic components supply chain. And in terms of semiconductor, you can see for the fabless sector, China has, as Cody mentioned, we own the 90% market share of the fabless revenue. And China grabbed 15%. And we believe, due to its large domestic market, Chinese fabless growth rate will higher than Taiwanese growth rate. So probably in 3 to 5 years, their market share will outpace Taiwanese market share. And for the IDM, as you see, Korea, like Samsung and SK Hynix, grab the most of the memory market share. And Japan has several important IDMs there, like Sony for CIS, like Renesas for MCU, like Qsha for flash memory, and so on. But for the foundry and the OSAT, Taiwanese company grabbed the most of the market share, 65% and 54%. Then, but you can see Chinese OSAT industry, they already grabbed 24% of the worldwide market. And I believe this market share will keep growth. But as for the equipment and the material, Japanese has a world best, one of the best equipment and the material industry, semiconductor industry here. Now, after I explain the details about the background of the Asia supply chain, then we can go to the Asia server supply chain. Okay, you can see, here's, I listed the top 60 ODM and EMS suppliers worldwide. And you can see the largest ODM and EMS suppliers come from 3 areas: Taiwan, China, and North America. Each suppliers from different regions has its own strengths. For the US EMS supplier, their strength is on industrial, like healthcare equipment and telecom equipment, and so on. And Chinese specialty is on consumer electronics and smartphone. As for Taiwanese, it's focused on computing and networking equipment. So you can see here, Taiwanese companies are the dominant PC and the peripheral suppliers. Here I use a notebook as an example. So 10 years ago, you can see Taiwanese produce 90% of the global notebook. And here's are the top 6 Taiwanese notebook suppliers: Quanta, Compo, Western, MediaTek, Foxconn, and Picatron. They extend their dominance, migrate to the server segment. So you can see, if we check server motherboard, we use server motherboard to represent, to check the global server market. So Taiwanese companies produce 90% of the server motherboard. Then you can see the same suppliers here: MediaTek, Foxconn, Quanta, Wistron. Wing is one of the affiliate of the Wistron group, and MediaTek and others. So here's the newest number of the server customer order allocation. You can see HP, Dell, Inspur, Lenovo, and the cloud service provider Google, Meta, Microsoft, Amazon, and Supermicro. How they allocate their order to the Taiwanese ODM suppliers. So when NVIDIA want to run its own AI server business, Jensen Huang need to count on Taiwan's supply chain. Here you can see, when Jensen has this H100 chip, then he needs Foxconn and Wistron to do the module, GPU module, H100 SSN. Then let Wistron to do the GPU baseboard, and let Foxconn to do the PCIe module. And NVIDIA control this module and baseboard, and allocate this kind of products to server brand and ODM, then to cloud service provider and enterprise. But also, NVIDIA has its own DGX system, NVIDIA brands AI server. And NVIDIA sell it to CSP and enterprise. So you can see, And we are so seriously to control the supply chain. Okay? And major CSPs all in high-end AI server, at least 8 GPU or AI accelerators. So you can see they adopt different model, but most of the AI server orders come to Taiwan. Supermicro Quanta, Weiyin Quanta, Wishong, Supermicro. And the DC system was invested by MediaTek. Here's the AI server supply chain. The company names in white color are from Asia. Okay, as you can see, chips, semiconductor mainly from the US, but the other parts mainly from Asia, especially from Taiwan. For example, foundry, design service, OC, substrate, and PCB, power supply, passive, fan, heatsink, case, and so on. But as for the optical module, besides the US supplier, there are many suppliers from China, because China has the most competitive optical module industry in the world. So here's our forecast for the overall server market. After year 2020, due to COVID, so you can see, drive the market demand fast and strong. For 2020 growth, 79%, 7%, almost 8%, then 60.5%. Then this year it's down 16%. Reason one is for demand shrink. And the reason two is that due to the lack of demand, but the cloud service provider, they already fixed their budget. They don't have enough budget to purchase AI server, while it's a hard issue. So they allocate their budget to purchase more AI server and reduce their purchasement for the traditional server. So the volume down. We focus the next 4 to 5 years. We think for generative AI, digital transformation, XR, and drive the market demand, slow but longer. So for the focus, we almost around 5% per year growth. And for the AI server shipment, we think that this year they are like 563K for this year. And in terms of the percentage of the total server shipment, it's only 3.7%. But as you can see, for year 2026, we expect the amount will increase to 1,780K. And the percentage in terms of the overall server shipment will increase to the 10%. And as for the high-end server, at least 8 GPU or AI accelerators, we think for this year, it's around 156K for this year. And the growth rate, as you can see, almost 150% growth. And for next year, it will increase to 272K. And the growth rate is still high, almost 75%. Now I would like to share about the geopolitics impact on AI proliferation. So after the trade war, supply chain split as two. One support China, one support non-China. So here you can see the distributed supply chain. As for server, you can see now many Taiwanese companies come to US and Mexico to do the server production, and also go to Chile and Germany, and also to Thailand, Malaysia, and Indonesia to produce servers. And if we check import numbers amount of SMT machine to learn supply chain migration trends, because when you check SMT machine, then you can know that they build their PCB capacity and assembly capacity, and will nurture the whole electronic supply chain. So as you can see, 2090, after 2090, that will be influenced by the trade war. You can see, if we count these 4 years, you can see China still have the world's largest import of SMT machine. So even after the trade war, they didn't slow down the capacity expansion. But you can see, if you add US and Mexico import amount, so the amount scale is similar to China's scale. So the supply chain try to support US market, so they build capacity in the US and in Mexico. And also you can see, we know that Vietnam is a winner after the trade war, because many companies move their factory to Vietnam. But Mexico's purchase amount still bigger than Vietnam. That's the truth that we didn't notice that. And also India, you can see, starting from 2018, the purchase amount become increased. So India now has more capacity and to nurture its local electronic supply chain. And last October, US done strictly export controls. It will impact on the IC product industry a lot. So we separate the market as 6 segments. For the right-hand part, US dominant market. CPU, GPU, FPGA, high-speed network chip. And for this area, memory. So US bank protect these 2 segments. This benefit to Micron, Samsung, and Cadence. This benefit to like NVIDIA, AMD, Intel, and Qualcomm and Marvell. So Chinese company, even though under this ban, they done a lot of effort to produce, to do their own design on CPU, GPU. And most of the team's background are from AMD, from Intel, from NVIDIA. But hard to do the relatively performance compared to NVIDIA and AMD. But they did try hard to produce this kind of product. And Chinese government will support it because it's too important for the AI development, for the semiconductor development. Okay? And the second area is on the mature process. China has already grabbed over 10% of the market share. These 2 segments also Taiwan's main target market, because China now only can offer mature process. So this market, like matured consumer electronic IC, analog, power management IC, discrete, those areas will, with the highest pressure from Chinese competitors. And we think they can grab more market shares. One, because currently there are too many fabless companies in China. And due to the restriction, due to the Chinese current economic situation is not quite well, so lack of the funding. So we think Chinese fabless industry will face a consolidation status. So money and the resource and the talent will consolidate to some companies. We think we'll consolidate to two kinds of companies. One is policy support companies, which is very important to the government and to the industry development for this area. And the second area for market winners, they do earn money. So people will join this company to join successful companies. And Chinese foundry only can provide the mature process technology. So the government funding will invest to this kind of mature technology. I think they will try to win market share in mature technology segment. So this kind of companies will grab more market share. And here's the wafer foundry's global layout. As you can see, before the trade war, wafer foundry primarily located in Taiwan, Korea, and China. Now after the trade war, not just US had the chip law, but also Japan and Europe. So they have put lots of funding to support their local production fabs. So like TSMC go to Japan, go to Arizona, and will go to Europe. So the situation is will different. So we also will have foundry service in every region. Now it's a conclusion. If you see the top market cap technology companies, we can treat it as two groups. One group is the big tech companies, Apple, Microsoft, Alphabet, Amazon, and Meta. And the second is semiconductor related, NVIDIA, TSMC, Samsung, Broadcom, SML. So these two groups are the two forces to drive the newest AI trend. So as you can see, big tech companies, their platform have more influence to the consumer side, and their cloud service have more and more influence to the enterprise. And they done more and more its own system products. Now they design more and more IC. So there's a vertical integration from downstream to the upstream. Here's the chips project that developed for the server, for the cloud. Not just for CPU, but also for the AI accelerator, for training and inference. Another trend, NVIDIA expand its role to the downstream sectors. As I mentioned, NVIDIA is really a fabless company right now. Don't you think so? So NVIDIA, its CUDA platform and its own brand server, and also NVIDIA launched its own cloud service for AI computing. So you see, NVIDIA's role is changing. So NVIDIA also do the vertical integration from upstream to downstream. So the dynamic of power structure between upstream and the downstream is happening. We don't know which side will win, but there are some bargain here. But we think no matter who wins, Asia supply chain helps customers, no matter it's cloud service provider or NVIDIA, to realize AI technology and make it affordable. And for us, DIGITIMES, we try to track Asia supply chain better and provide insight and news more deeply to our Silicon Valley readers. Thank you.
All right, so we've talked a lot about the, what are the drivers, and we saw predictions, we get them all the time. Semiconductor revenue is going to double, it's going to be $1 trillion, whatever. Like Finbar says, I can't predict the future, but I'm excited about it, right? All of these things that you see here are not new. I mean, you guys know all about hyperscale computing and automotive, AI, ML verticals and all the applications. But we kind of see these as the waves of change, the waves of innovation that we want to develop our products for. And like Finbar, I'm not going to give you a Cadence pitch, but I'm going to give you a perspective of what we look at and how we've developed our strategy for growth and for making customers successful. And also, another thing that's important to us at Cadence is keeping our employees happy, keeping them engaged, right? So you can see some of the trends here. We know that as products become more complex and more refined and offering different options and functionalities, we're going to see more chips being designed. I think, when you look at when I think about the first car that I bought, 1982, I think if it had a chip on it, it was probably because somebody chipped my windshield, right? Now, when you think about the number of chips in a car, I was talking to an aerospace design engineer who designs Formula One cars. And he was telling me that there are over 300 sensors on a Formula One car. Just sensors. He wasn't even talking ECUs or anything like that. So the increase in content is just going to continue to explode, I think. And I think a lot of that is going to be driven by the need for more AI applications, end applications, right? The complexity of what companies like, customers like you, people like you are designing is increasing, tenfold or more. I mean, the example from MediaTek, all of those examples were showing from generation to generation increasing complexity, whether it's, to enhance video or audio or manage power, right? And another thing that's happening that we can't ignore, there is a demand for more engineers. I think I've seen some statistics. So I was a EE, graduated in 1985, and I've seen statistics saying that currently at this point in time, less than 1% of the degrees being offered, awarded to undergraduate students coming from colleges, it's less than 1%. So when I was in school, I know EEs were pretty popular, along with chemical engineers and things like that. Now, the focus on electronics or electrical engineering, it seems to be losing fame and fortune for other things like, maybe computational software or computer science or math. I talk to a lot of kids in high school as part of my job. I do a lot of outreach in the community. Many of them want to do things like illustration, like get a job at Pixar or something like that, right? So all of these things are really vying for the attention of how we're going to grow our market and how we're going to continue to stay competitive and develop these products. So in the scope of what we do, we want to enable our, when I'm asked, what is Cadence, what do we do, right? We used to say we're an EDA company, and I grew up in EDA. I was a designer at TI for about 4 years. We had our own software, right? We had our own schematic capture, we had our own layout, we had our own IC verification, we owned simulators, everything. And I watched as the industry moved from in-house tools to more of the, OEM or third-party solutions from the big software providers. And it was always focused in very narrow areas, right? Very concentric, very contained, rather, areas. If you were designing a chip, you design the chip. And when you were done with the chip, you put it in, somebody else put it in a package, somebody else put it in a board. I was working on the next chip, right? And with the stack that we have here, as the functionality gets increases, the complexities increase more, you can't just stop at the chip, right? So now the chip designer has to work with the systems integrator and has to work with the end product, whether it's a car or a refrigerator or a computer or a data center. Doesn't matter. Now the electronics has to comprehend everything. I think when I was designing chips, it was a very easy thing to do because I only cared about one thing, right? And the one thing was performance of the chip. We had to meet a certain frequency. Then we moved into, now I have to care about performance and power. Then we moved into performance, power, and area. And then you had to deal with other things like crosstalk and all of that. Now that it's even worse, right? We have more variables that we have to concurrently design for. And by the way, we were tackling those problems pretty serially, sequentially, right? So all that to say that in the scope of things, all of this is driving complexity. So at the core, we still focus on having the best engines possible to develop the core piece of business that you have, right? And in our case, it's mostly been semiconductor devices. But those devices end up on a system or a board. And then to make sure that you can have integrity at that level, we have to incorporate more things to analyze, which we call systems design analysis or computational fluid dynamics, right? And then on top of that, we've been talking about intelligent design, right? Using the data to make better decisions. And 5 years ago, I don't think many people were really talking about AI or generative AI. It was all machine learning and deep learning and things like that, right? So that's still there, but now we're taking it to another level and having more of the reinforcement learning, still with human feedback, making these decisions. So that's what kind of drives our strategy, right? And the only thing I want to say here, there's really nothing different about the previous slide except that as you see these verticals that go across the top, the cool thing about it is those aren't all of the verticals, right? There are verticals on there that computational software can address that we're not talking about today, right? There's a new area that we're getting involved in that I'm not going to talk about today, but I'm going to mention it now because it doesn't have to do with chips. It has to do with life sciences. And so as a computational software company, when you think about what that really means, it's about solving these very complex systems or graphs or gradients or whatever for electronic design. That's where we got our expertise. Then we move from electronics to the physical world. What happens with thermal, what happens with EMI, electromigration, and things like that. About 5 years ago, we made a decision to move into what we call computational fluid dynamics or multi-physics analysis, right? The reason why we did that is because it's still computational software, which is still our core area of expertise. It's still math, right? And so we're applying all these things. So now we're, getting into the place where we can work with car manufacturers on the design of the car, airplane manufacturers, boat manufacturers. But computational fluid dynamics extends also to the medical profession, and even construction, right? So I learned a new one. One of the cool things about the job that I have now is I get to learn a lot of new things. And one of the things that I learned is that when you're looking at, we went through a pandemic, a few years back, and one of the things that people cared about was how does a virus travel? When it's airborne. If I'm in a plane, am I going to have a problem if someone coughs in the back, right? Well, you can do an analysis of what happens in the plane. And I'm sure you guys know this. That's a CFD problem. That's a CFD simulation, right? So we've acquired technology. We've developed technology around CFD to look at what can happen in a hospital or a school. And that technology is really derived around what can happen with a data center. We acquired a company called Future Facilities that is known for modeling the emissions and thermal dissipation of a data center from the ceiling to the floor and everything in between. So they can model all of the HVAC. They can model the electrothermal properties of the chips, the cabinets, the boards, and so we have a full solution there. Anyway, all that to say that there are other verticals that we can apply to. One that I will mention in life sciences is drug discovery. I didn't realize that drug discovery, when you're designing drugs for like a vaccine or something, that's another CFD simulation, right? How molecules get absorbed in tissue or whatever. So anyway, that's when we talk about our intelligent design strategy. That's what we're talking about. But now bringing it back to the topic of the day with semiconductors and chips and boards and things like that, I just kind of described how when I started out, the number of variables we had to model were pretty manageable. You could one or two hands and you could name what you had to look at. But complexity increases following Moore's law, and it's not KT Moore's law, it was Gordon Moore, right? But following that law that, frequency and capacity was doubling every 18 to 20 months. And we're at a point now where, Finbar and I were talking, prior to getting here, and it's amazing, when you think about the number of elements in a chip, and it doesn't matter what node, whether it's 5, 3, 7, doesn't matter. It's amazing that the things ever work. I was looking at your slides about all your products, and I mean, there are billions of elements, right? And if just one of them is potentially off by an angstrom or, I don't know how people sleep at night when they tape out. That was another reason why I had to stop being an engineer. I couldn't, every time I taped out, I was just, anxious the whole time, right? But now, we have all of these really complex devices that have been designed over and over and over again, with some derivatives and things like that. And we're just getting to the point now where the next generation or the next derivative is going to take even longer. So why are we talking about AI? Because AI can address that, right? So when Finbar was talking about AI, it was more about what's in the chip and what the chip can do. What I'm going to talk about is what AI can do in our software to help enable our customers like MediaTek or NVIDIA or someone like that to design these things with confidence, and not have questions about, well, did I miss anything, right? So that's the whole point. So I kind of talked through this already. In the early days, it was just human judgment. You knew what you knew, and you knew what to do, but you were never really sure about what you didn't know. Did I develop that last test to catch that fault or whatever, right? So this is pretty familiar. We all know this. As we moved into, I think one of the things that changed our paradigm in design was the growth and acceleration in compute power. You know, I think when I was designing, we were only talking about like x86 kind of, you know, there was a 2 and then there was a 3 and there was a 486, right? And then, but now we talk about multiple CPUs coupled with GPUs to give you this incredible compute power. And I think I saw a graph from the MediaTek presentation. See, I told you, you rocked that presentation. You had a lot of good data in there. And the graph showed, you know, like a low slope in the beginning of capability. And then with the advent of more AI technology, you know, it's almost asymptotic, right? So, you know, we're kind of right now just talking about maybe the power of the algorithms getting accelerated by compute. And that was, you know, let's say the late 90s, early 2000s, right? But now with these models of, you know, AI, whether it's, you know, machine learning or whether it's reinforcement learning or whether it's large language model, the opportunity here is to cover more of the universe of your design options with the same or fewer resources, and give you the opportunity to expand your thoughts, expand your creativity, right? So this is what's really exciting about AI, and that's what we want our software to do, right? We want our software to be able to take what was originally a single process, right, and make it into a massively parallel process for the individual. And so this is probably the closest I'm going to get to naming Cadence names, but before I do that, the bottom part of this chart here talks about some of our technology, right? Whether it's Jasper, whether it's Spectre, Innovus, Liberate, and what those products are, what we want to call those like best-in-class engines, right? And we've done a lot of work with ML, with some AI architecture to make those products better. But I want to give you an example of what that means. Because when we were improving those products, you know, we weren't really saying it was AI, right? We have an analogy of inside out and outside in. I think you mentioned that in one of your comments, or Kali did. But for us, when we make a piece of software faster, or when we increase its capacity, its ability to, you know, handle more objects or do more concurrency, that's more of an inside out, right? It's like taking a Mustang with a 4.0 liter engine, and you change the engine out for a 5.0 or a V8 or something like that, right? And so you can drive the car faster, but you still got to put your hand on the wheel, right? You still got to put your foot on the brake or the gas, so you don't change in principle the interface between you and your car, right? But as we talk about AI-driven platforms, that's really more transformational. It's really more like autonomous driving versus driving, right? And one of the keys that's going to be really critical to make this work is the data. I think about 10 years ago, somebody was talking about, you know, one of the industry taglines was, data is the new oil, right? I think we all heard that. And that's true, but it's only good oil if you're making good use of it, right? So one of the challenges is, how do we make use of all this data? Well, when you think about how you build your products, you might have, you know, engineering data in one place in your company. You might have manufacturing data in another place. You might have all of the requirements for your regulatory sign-off requirements in another place. So an area that we invested, this is part of our strategy, is to build, you could call it a data warehouse, which is what a lot of people refer to these things as, but it's the place where all the data lives that comes from all the disparate tools, that when you put the AI system together it can access all that data and access it quickly. And so I'm giving you the bottoms up, top down view of how we build our AI solutions. So when we talk about Cerebrus, I'll just talk about one, and then I can show you some examples. So I'll talk about Cerebrus for one reason. That was one product name that I came up with that stuck. Every other product name, Finbar, every idea I ever had got shot down by somebody else, right? But Cerebrus stuck because it was like, we were trying to put the brain into our digital RTL to sign off flow, right? And so, what Cerebrus does is it has, language model, learning, reinforcement learning. It has the ability to incorporate large language models and things like that. But it takes the RTL, the behavioral description, with your inputs for your target frequency, PPA, whatever, and it will crank on the design and try to give you, your desired result. Now, that principle applies to every one of these other AI platforms we have at the top. The Virtuoso Studio we just announced, which is more for the custom analog design space, right? And if anybody in here is an analog designer, I know you're going to say BS, it'll never happen, right? Because all analog designers don't believe that you can automate or optimize analog design better than they can. But anyway, we have it there. And then Verisium is our verification suite of tools, more at the hardware level. Allegro XAI is our PCB platform that incorporates AI. And Optimality, kind of brand new for us, but Optimality is for our CFD solutions when it comes to the multi-physics analysis. And so we're bringing all of this AI techniques, reference and learning, reinforcement learning and machine learning into our platforms. And it's going to extend. We're going to continue to create more. But this is just one example of the flow in Cerebrus. I don't know if this, I don't think the laser works. Oh yeah, it kind of does. But like if you look at scenario one, that is your RTL, typical RTL through sign-off design flow. And this is how we describe how the data flows through. And so it's more like you have one designer that can now explore multiple options. We had a customer, I'll just talk about it here on the next slide. We had a customer, these are some of the results. The top row talks about leakage power improvement. The middle row talks about productivity improvement, and the bottom row talks about another timing improvements. But we had a customer take one of their designs that they optimized with their best engineers. And however long that took, right? We started with their best optimization and improved total power like 8%, right? Over what they thought was best. And we did it in a much shorter amount of time, right? So and these are real numbers, right? I mean, from real customers. So you can just see that it's pretty transformative. And we've had many tape outs in silicon that's in production and working with generative AI for our RTL solution. Similarly with PCB. Now PCB is interesting because it's still very interactive and very manual. And again, when you think about chips, billions of elements and tens of layers of routing, and each layer is very expensive. But boards, you're trying to do, you don't have the capacity problem, but you do have the regulatory challenges of how do I place things, and am I going to meet FCC, or am I going to meet some automotive requirement? So with Allegro AI, XAI, we're able to automate that process so that you can have, again, a better chance of exploring where's the best starting point to get to my best endpoint, right? So similarly, we have examples of how we can reduce time, in various stages of the design process. And the small print there, while maintaining 100% manufacturing compliance, right? And that's really important. Right? That's really important. So these are just examples. I think last example here is with optimality, which is a new space, right? The CFD, when you look at solutions for multi-physics analysis, they've been around for a long time, and it's kind of like an expert area. So we're considered to be new to this area, but we have been doing CFD in various applications around thermal and power analysis for a while. But in this case, what we're able to do is not only look at multiple multi-physics analysis techniques, whether it's for power or electromagnetics or just general CFD for like aerodynamics, but we can also include the electrical elements, like whether, from the chips to the boards to the casing that it's in. Like if you had a cellular phone, at some point you want to know all things about the phone, right? How's it going to react in extreme conditions, whether it's in the middle of the equator or on either pole, north or south pole, you're going to have extreme conditions. And all of our products need to now think about that. I mean, just managing a camera in extreme temperatures, deep space, deep ocean, there's all these different forces that you now have to account for. We're able to provide that kind of analysis in context, and you can see again some of the benefits that customers have seen. And so I'm actually wrapping up with this slide, because I think at this point you've gotten a dose of this from the semiconductor side from our friends at MediaTek, and I'm sure some of you have seen in your own work what's important. But I think from a software standpoint, what our industry brings to the table is the ability to do things you haven't been able to do before. I mean, that's what every version of our software enables, right? The next version, we only come up with the next version because somebody in this room said, I need to do X, and I can't do X today, right? And so we don't say it's impossible, right? We look for ways to enable that. So with that, I will say I want to thank DIGITIMES for inviting us, Kali, and also want to pay respects to Finbar. Great presentation, and thank you guys for staying awake and listening after lunch. And I'm done. Thank you very much.